Hello friends, welcome back to another important video. In today's video, we are going to cover conceptual questions from the chapter Measures of Dispersion from your ABM paper of CAIIB. Now this is very important chapter from your statistics module of ABM. Many students simply leave this module because of mathematics involved, but mind you, this module is very easy and scoring if you grasp the concepts well. So this video will cover many conceptual and application based questions that have very high probability of coming in your examination. Also, I have made this full playlist of ABM videos for all the CAIIB aspirants. The link for this playlist is there in description of this video, so don't miss to watch other videos for your best practice. So with this, let's start with today's video. And the first question is, quartile deviation is also known as, and these options are given to you. That is, first option is interquartile range. Then second option B is semi-interquartile range. Then third option C is standard deviation. And last option D is coefficient of variation. Friends, please note quartile deviation measures the spread of the middle 50% of the data, as you can see in this image. Unlike range, it ignores extreme values and focuses only on the difference between the first and the third quartiles. So the formula to measure quartile deviation is very simple. That is, quartile deviation equals Q3 minus Q1 divided by 2. Here Q1 is first quartile, that is 25th percentile, and Q3 is the third quartile, that is 75th percentile. Now this makes quartile deviation half of the interquartile range. Also note, since it focuses only on central data, it is not influenced by the outliers. However, it ignores 50% of the observations and cannot be mathematically treated. Hence it is called semi-interquartile range. Thus the correct option for the given option is option B. Then next question is, a bank tracks the weekly share price of a borrower's listed company. Now these are given the share prices. Then what is the range of share prices? And these options are given to you. Now friends, in credit assessment, bankers often look at volatility of the borrower's stock price. And a simple way to measure the spread is range, which is nothing but largest minus smallest value. Here, as you can see, the largest value is 250 while smallest value is 160. So range is nothing but L minus S, that is 250 minus 160 equals rupees 90. Thus the company's stock fluctuated by rupees 90 during the week. Friends, such wide fluctuations may indicate instability and higher credit risk. So as far as this question goes, the correct option is option A. Now before moving on to the lecture, one hurdle that every CAIIB aspirant faces is completing the bulky syllabus. Time is less but syllabus is huge. So to counter this issue, I have prepared these secret sauce notes, which are in fact summarized notes of all the 4 papers of CAIIB. With these notes, you can eliminate your bulky textbooks altogether. These notes, along with my question banks, have proved to be the game changer for many CAIIB aspirants. All the links to get these notes are there in description of this video, so don't miss to get these notes for enhancing your passing probability. Then next question is, the loan amount sanctioned in a small MSME portfolio, that is rupees in lakhs, is given here. Now find the quartile deviation. And these options are given to you. Friends, please note quartile deviation is very important concept from dispersion topic. And year on year many questions are asked from this part in ABM paper. So please remember, quartile deviation is half of difference between third quartile, that is Q3, and first quartile, that is Q1. It shows the spread of middle 50% of data and is useful for bankers in understanding lending concentration. Now the number of observations, as you can count here, is 8. So Q1 is simply value of n plus 1 by 4, which is 9 divided by 4 equals 2.25th item. And this lies between second, that is 15, and third values, that is 20. So Q1 is simply 15 plus 0.25 multiplied by 20 minus 15 equals 16.25. Similarly, Q3 is value of 3 multiplied by n plus 1 by 4th value, which is 27 by 4, which is 6.75th item. And this lies between 6th, that is 35, and 7th value, that is 40. So Q3 is simply 35 plus 0.75 multiplied by 40 minus 35 equals 38.75. So quartile deviation can be simply calculated as Q3 minus Q1 divided by 2, which equals 38.75 minus 16.25 divided by 2, which equals 22.5 divided by 2 equals 11.25. So friends, this shows that the middle 50% of loan amounts deviate by about rupees 11.25 lakhs around the central values. As you can see, this highlights a moderate spread, showing lending is not tightly clustered and indicating some diversity in sanctioned loan sizes. Now, with respect to this question, the correct option is option A. The next question is, Bank A has an average term deposit balance of rupees 50 crore with a standard deviation of rupees 5 crores. Bank B has an average term deposit balance of rupees 80 crores with a standard deviation of rupees 12 crores. Which bank has more consistent deposits? And these options are given to you. Now friends, please note, coefficient of variation allows bankers to compare relative variability between groups with different means. Also remember, lower coefficient of variation also indicates more stability. So as you can see that coefficient of variation is a relative measure of dispersion expressed as a percentage. It relates the standard deviation to the mean, making it dimensionless and suitable for comparison. So as you can see, coefficient of variation is simply calculated as sigma divided by x bar multiplied by 100, where sigma is standard deviation and x bar is arithmetic mean. Next, let's calculate the coefficient of variation for each of the banks A and B. So for Bank A, coefficient of variation is simply 5 divided by 50 multiplied by 100 equals 10%. Similarly, for Bank B, coefficient of variation equals 12 divided by 80 multiplied by 100 equals 15%. Finally, since 10% is less than 15%, Bank A's deposit is more consistent, which is preferable for liquidity management. Thus, the correct option for the given question is option A. The next question is, a credit manager is reviewing the overdue days of 5 loan accounts. Now these are the overdue days given for the loan accounts. Then calculate the mean deviation about the mean, and these options are given to you. Friends, mean deviation measures the average of absolute deviation from a central value, be it mean, median or mode. Basically, it helps bankers to assess variability in repayment days. Now in this question, we need to find the mean deviation about the mean. So let's first find the mean, that is x bar, which is 8 plus 12 plus 15 plus 20 plus 25 divided by 5 equals 80 divided by 5, which is 16. Then next we will find the deviations from the mean of all the days, which is absolute value of 8 minus 16 equals 8, then absolute value of 12 minus 16 equals 4, then next absolute value of 15 minus 16 equals 1, then next absolute value of 20 minus 16 equals 4, and finally 25 minus 16 equals 9. Now please note, the use of absolute value means we are ignoring the negative sign. So total absolute deviation is simply 8 plus 4 plus 1 plus 4 plus 9 equals 26. Finally, mean deviation is simply 26 divided by 5 equals 5.2. And this shows that average delay is around 5 days. Thus the correct option for the given question is option B. Then next question is, 3 bank branches report their average loan sizes and number of loan accounts as follows. That is, branch A has mean loan size of rupees 4 lakhs while number of accounts is 50. Then branch B has mean loan size of rupees 6 lakh. Number of accounts equals 70, while branch C has mean loan size of rupees 8 lakh while number of accounts equals 80. What is the combined mean loan size across all the 3 branches? And these options are given to you. Friends, please remember, when combining multiple groups, we can't simply average their means. Instead, we must compute a weighted average where each group's mean is weighted by a number of observations. So this gives the combined mean, which represents the central value across all the series. The formula of this is very simple. That is, x bar 1, 2, 3, that is for first, second and third series, is simply n1 multiplied by x1 bar plus n2 multiplied by x2 bar plus n3 multiplied by x3 bar, and whole of this divided by n1 plus n2 plus n3. Now N1 is number of items in first series, N2 is number of items of second series, N3 is number of items of third series, then X1 bar is arithmetic mean of first series, X2 bar is arithmetic mean of second series, and finally X3 bar is arithmetic mean of third series. So just pause the video and try to substitute the values given in the question into this formula. Now after substituting, you will get numerator as 50 multiplied by 4 plus 70 multiplied by 6 plus 80 multiplied by 8 and divided by 50 plus 70 plus 80, which equals 1260 divided by 200 equals 6.3. So the combined mean loan size is simply rupees 6.3 lakhs. Thus the correct option for the given question is option B. The next question is, a bank branch conducted a survey of the monthly salaries given as rupees in thousands of its clerical staff. The group data is given below. Now friends, as you can see in this table that we are given the salary range and then number of employees getting that salary. Now using the formula for median in the group data, find the median salary of the clerical staff, and these options are given to you. Now friends, if you see my ABM notes or even your textbook, you will see that for the group data, the median is not directly observed, but it is estimated using the interpolation formula, which is m equals L1 plus n divided by 2 minus c multiplied by f, whole of this divided by f, and multiplied by L2 minus L1, where L1 is the lower boundary of the median class, L2 is the upper boundary of the median class, f is the frequency of median class, C multiplied by F is the cumulative frequency before median class, and capital N is total frequency. So let's calculate all these values one by one. So in step 1, the total frequency, that is capital N, will be simply 5 plus 8 plus 12 plus 20 plus 10 plus 5, which is equal to 60. And also capital N divided by 2 equals 30. Then in step 2, we will identify the median class. And to find this, we will make this cumulative frequency chart. That is, up to 20 we have 5, then up to 30 we have 13, up to 40 we have 25, up to 50 we have 45, and then up to 60 we have 55 clerks, then up to 60 we have 55 clerks, and finally up to 70 we have 60 clerks. Now friends, I hope you know how to find this cumulative frequency. That is, this first line, that is up to 20, 5 is given. Then when you add 8 to 5, we get 13. Then next, when we add 13 to 12, we get 25, and so on. Now since capital N divided by 2 equals 30, so the cumulative frequency just greater than 30 is 45. And this lies in the 40 to 50 class. Hence, median class is simply 40 to 50. Then finally in step 3, we will substitute the values into the formula. I hope by now you can make out that L1 is 40, L2 is 50 here, C multiplied by F is 25, that is cumulative frequency before 40 to 50 class, and frequency is 20, that is frequency of the median class. So let's substitute all these values in the formula. We get m equals 40 plus 30 minus 25 divided by 20 multiplied by 50 minus 40. And on solving this, you will get 42.5. Thus the median is simply rupees 42,500. So the correct option for the given question is option D. Then next question is, at a bank branch, the frequency distribution of daily ATM withdrawals, that is in rupees in 100, is given below. Now as you can see in this table, the withdrawal range is given and also number of customers are also given for that range. Now find the mode of ATM withdrawals using the group data formula. And these options are given to you. Again friends, if you see my summarized notes for group data, the mode is the value corresponding to the class interval with the highest frequency, that is the modal class. It is simply estimated by interpolation using this formula. That is, Z equals L1 plus F1 minus F0 divided by F1 minus F0 plus F1 minus F2 and whole of this multiplied by L2 minus L1. Where L1 is lower boundary of modal class, L2 is upper boundary of the modal class, F1 is frequency of modal class, F0 is the frequency of the class before modal class, and finally F2 is the frequency of the class after modal class. So let's start solving this question. Now in step 1, we have to identify the model class. Now as you can see, the highest frequency is 40 for the class 200 to 300, which implies model class is simply 200 to 300. So with this, you can easily find the values of F1, F0, F2, L1 and L2. That is, L1 is simply 200, L2 is 300, F1 is 40, F0 is 25 and F2 is 35. So just substitute all these values in the formula. We get Z equals 200 plus 40 minus 25 divided by 40 minus 25 plus 40 minus 35 and whole of this multiplied by 300 minus 200. And on solving this, you will get Z equals 275. So the correct option for the given question is option C. Friends, finally we have reached the final question of this video, and the question is, a regional bank wants to study the variability in loan processing time in days for personal loans. The data for 9 completed cases is, and this data is given to you. Management decides to calculate the coefficient of quartile deviation to measure how consistently the processing times are clustered around the central values. What is the coefficient of quartile deviation? And these options are given to you. Friends, we have already seen in the previous question that quartile deviation is simply Q3 minus Q1 divided by 2. But please note, this question asks for coefficient of quartile deviation, which is a relative measure of dispersion useful for comparing variability in service or operational data across the branches. So coefficient of quartile deviation is simply Q3 minus Q1 divided by Q3 plus Q1. Now step 1 is arranging the data, and if you see carefully, then the given data is already given in ascending order. So number of values, that is n equals 9. Then in step 2, we will find the value of Q1 and Q3. Now we have already seen Q1 equals n plus 1 divided by 4 equals 10 by 4, that is 2.5th value, which lies between the second, that is 9, and third value, that is 10. Which implies Q1 is simply 9 plus 0.5 multiplied by 10 minus 9 equals 9.5. Similarly, we have also seen that Q3 is calculated as 3 multiplied by n plus 1 divided by 4, which equals 7.5th value. And this lies between the 7th value, that is 18, and 8th value, that is 20. Which implies Q3 equals 18 plus 0.5 multiplied by 20 minus 18 equals 19. So by putting all these values in the formula of coefficient of quartile deviation, we get Q3 minus Q1 divided by Q3 plus Q1 equals 19 minus 9.5 divided by 19 plus 9.5 equals 9.5 divided by 28.5, which equals approximately 0.33. Friends, this simply means that loan processing times deviate moderately, that is about 33% around central quartiles. Also note, a lower coefficient would indicate more consistency in loan processing. So the correct option for the given question is option D. Friends, with this I wind up this video. I hope all the questions from this chapter are clear to you. Also don't miss to get your CAIIB resources, especially these summarized notes and question banks from the links given in description of this video. So thank you, and I will meet you again in another video next week.